Can you solve this question? It looks complex, but it is actually very, very simple. Now it says that given that a equals pi r squared plus pi r into bracket a squared plus r squared, we should show that h equals square root of a over pi r plus minus r into bracket 1 plus r. Oof, like a lot of work, but it's actually very simple. What we have to do here is just to make h the subject of this formula. Then we simplify until we get something like this, as easy as that. So now let's make h the subject of the formula above. To make h the subject of this formula, it's very simple. It means we have to isolate h at this right hand side, right? Any letter or symbol or number that is not h, that is at this right hand side, we should get rid of everything. Now let's start by getting rid of the leftmost part, which is pi r squared. It is an added term, so we get rid of it by transposing. Take it to the other side, it becomes negative. And we have a minus pi r squared equals pi r h squared plus r squared. Now the next one is pi r. Get rid of pi r. Pi r is a coefficient of this bracket, so we get rid of coefficients not by transposing but by dividing through. So we divide through by pi r. So we have divided by pi r divided by pi r divided by pi r. So here pi cancels pi, then r cancels one of the r here, pi r cancels pi r. So we're left with a all over pi r minus, we are left with one r here because here is squared, r equals, now the bracket is open, we have cancelled the coefficients. So we have a squared plus r squared. The next thing to do now is to get rid of this r squared. It is an added term. We transpose it, it becomes negative. So we have a over pi r minus r squared minus r equals h squared. So I could have written it as negative r squared plus, but it looked too clumsy. So that's why I just make it like this. It's the same thing, no difference. H squared. We're almost there. Let's flip this equation because we like h to be at the left hand side. So we have h squared equals. Now, lastly, let's take the square root of this side so as to make h totally isolated without no square. Then we have h equals square root of a over pi r minus r squared minus r. Now we have successfully made h the subject of formula. We should have stopped there, but the question says that we should show that h equals this, not this. Now what is the problem? A over pi r, a over pi r. We are good to go. Now here we have a bracket here. We don't have any bracket here. So we have to make this look exactly like this. By doing what? Yes, you guessed right. By factorizing. So we factorize negative r because it's common. So we have h equals square root of a over pi r. To factor out negative r into bracket. Negative r squared divided by negative r, we have r. Minus cancel minus, r cancel r, we have plus 1. Therefore, we can write it as h equals square root of a over pi r minus r 1 plus r. Very easy. Therefore, we have shown that h equals this. It is exactly the same thing. As simple as that. So thank you very much for watching. Bye bye.